Hi everyone. In this video we are going to see the relation between all types of numbers. You have already learnt in my introduction video about natural numbers, whole numbers, integers, rational numbers. Okay, we'll see the relation between all the numbers. First we'll take natural numbers. Okay, natural numbers. What are natural numbers? 1, 2, 3, so on are called natural numbers. If we add 0 to this natural numbers, okay, what do you get? If you add 0 to this natural numbers, you get whole numbers. Okay, 0, 1, 2, 3 are whole numbers. They are called whole numbers. Now, if you add negative numbers to these whole numbers, like -3, -2, -1, these negative numbers, what do you get? You get integers. Okay, when you add negative numbers to the set of whole numbers, you will get integers. Okay, what if you add all the p by q forms of numbers? P by q form, for example 22 by 5. If you add this kind of numbers, you will get what? Rational numbers. Okay, these are called as rational numbers, and rational numbers are denoted by q. So what conclusions can we draw from this? We know that natural numbers equal to 1, 2, 3 and so on. If we add 0 to the set of natural numbers, these are all natural numbers. So for natural numbers, if we add 0, we get whole numbers. So we can say that, what conclusion can we draw? We can say that every natural number is a whole number. But every whole number is not a natural number. Why? Because, for example, 0. If you take 0, 0 is a whole number, but 0 is not a natural number. Okay, that's the reason we say, what is the first conclusion we can draw? Every natural number is a whole number. Every natural number is a whole number. But every, I am using the word every here. See this, every whole number is not a natural number. Okay, why? Because if we take 0 from whole number, 0 is not a natural number. That's the reason we say every whole number is not a natural number. Next, we'll see the set of integers. How do you get set of integers? You'll get when you add negative numbers to the set of whole numbers. Okay, to the set of whole numbers, you add negative numbers, then you get integers. So what conclusion can you draw from this? Every whole number is an integer, but every integer is not a whole number, because these negative numbers don't lie in the whole number set. Okay, so what can we say? Every whole number is a integer. Yeah, but every integer is not a whole number. Okay, you understood, right? Next we'll see rational numbers. What does rational number has? All which are in the form of p by q, 25 by 5, 22 by 5, 17 by 10, so on, like this, which are in the form of p by q. I can write 2 also, because 2 can be written as 2 by 1. Okay, if I can write -3 also. -3 also can be written as -3 by 1, like that. Okay, these are all rational numbers. If now you can say that every integer is a rational number. Every integer is a rational number, because every integer can be written in the form of p by q. That's the reason we say every integer is a rational number. But every rational number is not an integer. Every rational number is not an integer. Why every rational number is not an integer? Because can this be an integer, 22 by 5? No, this cannot be integer. This is in the form of fraction. Can this be an integer? No. 17 by 10. These are the example. We say these are the examples. That's why we say every rational number is not an integer. Okay. Now we will understand the concept with the help of an example. Here is a question. From example 2, the question is, are the following statements true? Give reasons for your answers with an example. They gave the first question as, every rational number is an integer. Is every rational number an integer? We'll see. We'll take an example and we'll check it out. I'll take the rational number as 7 by 8. Okay. Is this the integer? No, this is a fraction. This is in the form of p by q, right? That's why it is a rational number where q not equal to 0. Okay, these two statements should satisfy for the number to be a rational number. Can this be an integer? No. 7 by 8 is not an integer. Therefore, what can we say about the first statement? It is false. First one is false. The example is this. Next question we'll see. The second one. The second one here is, every integer is a rational number. We'll check it out. We'll take some integers. I'll take -2. Is this a rational number? Yes. Why? It can be expressed as -2 by 1. Isn't this the form of p by q? Yes. It is in the form of p by q and q is not equal to 0. I'll take the other integer. I'll take 55. Can 55 be expressed in the form of p by q? Yes. You take the denominator as 1. 55 by 1 is nothing but 55. So this is in the form of p by q and q not equal to 0. So these two conditions are satisfied. So every integer like this can be expressed in the form of p by q. What is it? Every integer can be expressed in the form of p by q. So what do we say? We can say that every integer is a rational number. Therefore, it is true. The second statement is true. Okay. This is false. The first one is false. The second one is true. What about the third one? 0 is a rational number. Okay, we'll see. We'll take 0. 0. Okay, I'll express 0 as 0 by 1. What is the value of this? Again 0. Okay, I can express it in the form of this. Here it is in the form of p by q and q not equal to 0. See, don't get confused. Here q is the denominator. Q is not equal to 0. There is no condition for p. It has to be an integer, that's it. P can be 0. Only q shouldn't be 0 for a number to be a rational number. I'll express 0 as 0 by 22 or else 0 by 100. These all values are equal to 0 again. So 0 is also a rational number. 0 is also a rational number. Okay. Therefore, what can we say about the third statement? It is also true. Okay, the third statement is also true. That's it. Thank you.